The third question on the January 15th page is you roll a six-sided die. If you get less than 4, then you roll an 8-sided die. Otherwise, you roll a 6-sided die. There's 6 possibilities then for what happens on the first roll. Now the question is, does the fundamental counting principle apply? You want to think through that question in terms of what we saw in the preceding for the switches. Okay, well, there's 6 possibilities for what happens when you roll the first die, as we said. How many possibilities are there for the second? Well, doesn't that depend on what happened in the first? If the first is less than 4, we're going to roll an 8-sided die, so there are going to be 8 possibilities. Otherwise, we roll a 6-sided die, and there are 6 possibilities. Okay? So, the number of possibilities for the second depends on the result for the first, so that we cannot apply the fundamental counting principle I'll write that in. Fundamental counting principle does not apply to the problem as stated. However, we can break this problem into 2 different sub-problems, okay? And the fundamental counting principle can be made to apply to the sub-problems, to the breakdown. So we break down into cases. So the first case is the first die is less than 4. In that case, then there are 3 possibilities for the first, because it's less than 4, that means 1, 2, or 3, and 8 possibilities for the second, because since we've rolled a 1, 2, or 3, we have less than 4, we're going to roll the 8-sided die. And in that case, we can answer, okay, subject to the restriction that the first die is less than 4, there are 3 possibilities for the first and 8 possibilities for the second, giving us 3 times 8 equals 24 possibilities. So the fundamental counting principle applies to this case. And it also applies to this case. So it applies to this case here, this case being where the first die is greater than or equal to 4. So there are 3 possibilities for the first in this case, 4, 5, or 6. 6 possibilities for the second, because having rolled a number greater than or equal to 4 that isn't less than 4, you're going to roll a 6-sided die, giving you 3 times 6 or 18 possible outcomes. The tree diagram for this situation, don't have room on the board, didn't have room on the board to write it, didn't want to go to another board and write it all out. But we see that there are a total of 24 plus 18, 42 possible outcomes, and we can represent that fairly easily by a tree. Okay, the first die is going to give us a 1, 2, 3, 4, 5, or 6. If we get a 1 or a 2 or a 3, there are going to be 8 possibilities off of each one of those. Now I haven't labeled them. I just barely had room to write these or to draw these 8 twigs for each of these possibilities, for each of these branches. But there will be 8 possibilities in each of these, giving us the 3 times 8, 24 possible outcomes. And down here there are 6 twigs, 6 little branches off of each one of these, giving us 3 times 6 or 18, 42. So this is kind of what your tree diagram would look like, and it's a handy way to visualize the situation. And we can say that the fundamental counting principle applies to this part of the diagram, and it applies to this part of the diagram.